Romania is one of the most seismically active regions of Europe. However, this might seem confusing at first. Romania is not located on or near any plate tectonic boundaries. So what explains their long history of damaging and deadly earthquakes? For that, we need to go back in time to about the late Mesozoic era. Pangea has broken up, so the Earth's continents are barely recognizable. However, a collision was taking place between the African and Eurasian plates. This caused a complex series of subduction zones to form within southern Europe. One of those subduction zones is located in the Balkans. The uplift of the land, combined with volcanism caused by the subduction zone, resulted in the formation of the modern Carpathians. While this subduction zone is long dead since, remnants of the subducting crust still remain attached to the surface in modern-day Romania. The weight of this ancient crust combined with the fact that the top of this ancient crust is still stuck to the surface means that tensional forces are building up in this ancient crust and that tearing has begun on this crust, which in theory would result in a lot of normal faulting. Now let's check those earthquake beach balls or moment tensors as they can say a lot about the faulting mechanisms involved. First impressions show that the thrust faulting is actually responsible, but we are forgetting that this ancient crust is diving near vertical towards the mantle. So viewing the beach ball from the side reveals that normal faulting is truly responsible for these earthquakes. Where there are mountains, there are thick layers of sediments nearby. Mountains erode and deposit these materials at areas of lower elevation. This usually results in a flat, fertile basin, perfect for building a civilization. But Mexico City has taught us that soft soil is a disaster waiting to happen. The intermediate depth of the earthquakes happening in the Vrancea region can be described as both a blessing and a curse. Intermediate depth earthquakes don't cause as violent of ground motions as shallow earthquakes, but they are felt at greater distances. Still, if you are near the epicenter, you could feel up to 0.4 G, not as violent as Kobe's 0.8 G or Northridge's 1.8 G, but that's still the equivalent of being in an airplane, and on the higher end, as airplanes at most expose passengers to between 0.2 to 0.4 G. This does mean that we should not underestimate the power of intermediate depth earthquakes. Even if the source of the earthquake is 90 kilometers beneath the surface, it still has enough power to be devastating at the surface. On the 4th of March of 1977, normal faulting occurred at a depth of 94 kilometers before propagating southwest. Seismic waves traveled up the subducting crust and spread out in all directions once it reached the surface. South of the epicenter, seismic waves were massively amplified by the soft sediments. On hard rock, seismic waves have low amplitudes and high frequencies. This feels like a vibration, or a quick jerking motion that isn't as damaging as accelerations unsustained over long periods of time. On soft soil, the ground rolls like a ship at sea. Accelerations are sustained for much longer periods. Plus, they naturally resonate with larger buildings. Bucharest, the capital of Romania, was full of these large buildings and suffered catastrophic damage there. Like in Mexico City, many mid-sized buildings collapsed, causing over 1,000 deaths. This is not helped by the fact that many of these buildings were built in the 1920s to the 1940s, where there are no seismic codes. Some buildings from the 70s also collapsed due to shoddy construction. Damage was also severe in neighboring Moldova and Bulgaria, despite the distance. For example, in the town of Svistov, Bulgaria, over 250 kilometers from the epicenter, three apartment blocks collapsed, killing 120 people, suggesting that at least Mercalli intensity 7 or very strong shaking had occurred there. Had this earthquake happened 20 or 30 kilometers beneath the surface instead of 94 kilometers, Svistov would have only experienced intensity 5 shaking or moderate shaking at most. This isn't the first time such a disaster has happened. Generally speaking, an earthquake of over magnitude 7.5 happens in the area every 80 years, over 7.0 every 33 years, and over 6.0 every 10 years. This does mean that Romania is due for a major earthquake in the near future. Historical data shows that earthquakes here can be rather terrifying. In 1802, an earthquake struck the Vrancea area. It had an estimated magnitude of 7.9 to 8.2 and caused damage as far as Moscow in the form of cracks in walls. What we can learn from this event is that high-magnitude, intermediate-depth earthquakes can devastate large regions. Due to the frequency of earthquakes in Romania, it may be a good idea to implement a Balkan-wide earthquake early warning system. Such a system already exists, however, is limited to a few key infrastructures like power plants and bridges. Reinforcing buildings should also be a priority. European buildings are often made of stone and brick. Strong, but under lateral stresses of an earthquake, they tend to collapse like a house of cards. Last but not least, education of the general public on how to react during an earthquake.